Welcome back to my series of videos about virtualization and cloud computing. In the first video, I talked about the motivation for virtualization. In this video, I'll be showing you what virtualization actually looks like. You'll recall the goal of virtualization is to make a single physical system look like multiple virtual systems. This concept is not new. In fact, computer virtualization has existed for proprietary platforms like mainframes for decades. In this discussion, though, I'll be looking at the most common virtualization technologies in use today. These are focused on so-called x86 technology. This is the platform that runs the majority of desktop and server operating systems, including Windows, Linux, Solaris, and Mac, although Mac is proprietary and not supported as a virtual machine. Central to the idea of virtualization is the hypervisor. This is an application or operating system that abstracts and controls physical hardware and partitions it into multiple environments. There are two basic kinds of hypervisors. A Type 1 hypervisor runs on so-called bare metal and is the primary operating system on that box. Examples include VMware ESX or vSphere, Microsoft Hyper-V, and Citrix Xen Server. A Type 2 or client hypervisor runs on top of an existing operating system. Examples include VMware Workstation for PCs and VMware Fusion for Macs, Sun/Oracle VirtualBox, and Microsoft Virtual PC. The hypervisor is responsible for abstracting and dividing up physical resources and managing them across multiple virtual machines or VMs. Let's have a look at virtualization in action. In this clip, I'll demonstrate VMware Workstation running on my laptop, which happens to be running Windows 7 as its base operating system. Remember that VMware Workstation is a Type 2 hypervisor. I have a number of virtual machines configured, including various flavors of Windows, Ubuntu Linux, and Solaris. Let's fire up the Ubuntu virtual machine. As you can see, the VM boots as if it were a physical system running on dedicated hardware. Now I'll log in. And here is my Linux desktop. If I click on an application, it runs just like it would on a physical system. Here's a word processor. And here's a web browser. While this is running, I can open other virtual machines. Let's take a trip back in time. This was state-of-the-art computing during the dot-com days. Good times, eh? Wait for it. As you can see, we now have two completely different computing environments running in VMs. The operating systems are different, and the applications are different. Let's start up one more operating system. This time I'll choose Solaris. And I'll run its Office application. So at this point, I'm running Windows, Linux, and Unix all at the same time. That's the beauty of virtualization. I can continue to open other VMs as long as I have enough system resources. When I run out, though, everything will grind to a halt. One of the keys to virtualization is the concept of overcommit or oversubscription. Basically, this is assigning more resources than you really have. For example, on my machine with 4 gig of memory, I might assign 6 VMs 1 gig each. Either I don't run them all at the same time, or I hope they don't all hit max load at once. It's kind of like a Ponzi scheme. If I do run into resource contention issues, I have to either run fewer virtual machines or add more physical resources. So that's a quick overview of what virtualization looks like at a basic level. In the next video, I'll look behind the scenes at how virtual machines are stored and managed. See you then.